Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the metric system. The metric system was developed a couple hundred years ago by a group of French scientists who wanted to make the system of measurement much easier than what it was. There was a lot of haphazard units, a lot of awkward numbers, and they determined that it was possible to develop an easier system. They did a couple of things that made it very easy. One is that they used 10 as their base for all of the units. There are 10 of something and something else. There's 10 of those and something else. So that already made it easier because our number system is based on the number 10. In addition to that, they determined a set unit as the base unit for every type of measurement that there was. So for example, for length, they determined the meter was going to be the base unit. For capacity, they determined liter was going to be the base unit. For mass, gram. For force, Newton. For power, watt, and so on. So there, for every type of measurement, there is a base unit. And all of those units tie in to the base unit of meter. They started with a meter. And to get an idea of what a meter is, it's this pink line here. That length is a meter. It's approximately 39 inches. The idea with the metric system is to be used by all countries. So they came up with symbols for the units rather than abbreviations. So the symbol for meter is a small m. There will not be a period. You won't see a period because it's not an abbreviation. The symbol for liter is capital L. You might see a small l, but the preferred symbol is capital L because then you won't mistake it for a number 1. The unit for gram is small g. And then with these base units, there's a set of what's called prefixes. I'm going to outline those prefixes, but these prefixes apply to every type of base unit. Let's take a look at them. In this video, we're just going to take a look at the prefixes between kilo and milli. There are prefixes greater than kilo, and there are prefixes less than milli. And I will address those in another video, but in this video, I just want to stick to these 6 prefixes as well as the base unit. So the first one that we're going to talk about is kilo. The symbol is small k, and it has a value of 1,000. So if we attach the prefix kilo to any base unit, it means 1,000 of that units. So a kilometer means 1,000 meters. A kilogram means 1,000 grams. A kiloliter means 1,000 liters. A kilowatt means 1,000 watts, and so on. Then there's hecto, which has a symbol of small h, value of 100. Deca, symbol is 2 letters, small d, small a, and its value is 10. Then we have our base unit, which has a value of 1. Then we have deci, symbol is small d, value is 0.1, or 1/10, but we don't use fractions with the metric system. So if we attach deci to the base unit meter, 1 decimeter means 0.1 meters. Centi, small c, 1/100th, which is 0.01. And milli, small m, which is a value of 1,000th, or 0.001. So if we were to take a look at length, our base unit would be meter. So a decameter would be 10 meters, hectometer is 100 meters, kilometer is 1,000 meters. If we were to take a meter and divide by 10, we would have a decimeter. So if we took this length and took 1/10 of it, we would have this length here. And a good reference for that would be the width of your hand, depending on how wide your hand is. But it just gives you a quick reference of what a decimeter is. If we took a meter and divided it by 100 and took one little piece, we would have a centimeter. So this is a centimeter, so it's about the width of the top of my baby finger. And if we took a meter and divided by 1,000, took 1,000th of this length, we would have a millimeter. And a millimeter is approximately the thickness of a dime or your fingernail. Just to give you points of reference for liter and gram. A liter would be the capacity of this container up to about here. If you want to compare it to something you're familiar with, if we looked at this container, this is about 950 milliliters, so it's almost a liter. 1,000 milliliters is a liter, so this is a little shy of a liter. And this would be the size of an American quart. So it gives you a point of reference for liter. And to get a point of reference for your base unit gram, a paper clip would be approximately the mass of 1 gram. You're going to want to be able to change from one metric unit to another metric unit, for example, with length. And it is a good idea to know these values, but I'm going to show you a fairly easy way to change from any length unit to another length unit fairly quickly without getting too hung up with these numbers. What I recommend you do is set up what I call a scale here from kilometer to millimeter. It's going to be all the prefixes we took a look at. And we're going to attach them to our base unit of meter. So we're going to have kilometer, hectometer, decameter, our base unit of meter, decimeter, centimeter, and millimeter. And one way to help you remember the order of those prefixes is a little saying that's going to sound silly, but it's very helpful. If you remember the first letter of ketchup has damaged my delicious chocolate milk, you've got your units in the correct order. Now, we know that if we start here and we move to the left, this unit is 10 times greater than this. Specifically, 10 millimeters are in 1 centimeter. 10 centimeters are in 1 decimeter. 10 decimeters are in a meter. 10 meters in a decameter. 10 decameters in a hectometer. 10 hectometers in a kilometer. And because when you move on your scale, you're going to be multiplying or dividing by 10. It's the same as moving your decimal point. So let me show you. If we had 4.25 meters and we want to know how many centimeters that is, we're going to be going from meters to centimeters on this scale. And each step on this scale, when we move to the right, we're going to multiply by 10. Each time you multiply by 10, you move your decimal point 1 place. So 4.25 meters, if we move our decimal point 2 places, it will be 425 centimeters. Let's do another example. We want to change 0.5 kilometers to meters. So we start with this unit. We're going to go 1, 2, 3 places to the right. So each time we move to the right, we multiply by 10. So in other words, we're multiplying by 1,000. Or in other words, we're moving our decimal point 3 places to the right. So we move our decimal point 3 places, we go to the end of the number, and then we put zeros in. So it will be 500 meters. If we go in the other direction, we're going to be dividing by 10. So we're going to move our decimal point to the left. For example, if I had 300 decimeters, be careful between decimeters and decameter. If I had 300 decimeters and I want to know how many meters that is, I'm going 1 place to the left, and I need to divide by 10. So 300 decimeters, move the decimal point 1 place to the left, will be 30 meters. If I wanted to change 1,500 centimeters to decameters, I'm starting with this unit. I'm going 1, 2, 3 places over. So each time I'm dividing by 10. So in other words, I'm dividing by 1,000, which means I move my decimal point to the left 3 places, exactly the same way I'm moving on my scale. So I move my decimal point 3 places to the left, and this will equal 1.5 decameter. So the beauty is you just need to move your decimal point to change units. There's no awkward numbers to multiply by. And the other amazing thing about the metric system is that what we did here to change units is going to be exactly what we do with changing units in mass, or in capacity, or in force, power, any type of metric measurement. All we do is use these prefixes and set up the same scale. Let's take a look at capacity. Here's our scale for capacity. All we've done is we've replaced our base unit of meter with the base unit of liter. And then we have our 7 units for capacity. And again, I can change from one unit to the other unit using the same strategy. For example, if I had 50 milliliters and I want to know how many deciliters that is, I start at milliliters and I see that I move 2 places on my scale to the left. So I do the exact same thing with my decimal point. So my decimal point's at the end of the number. If there's no decimal point there, I move it 2 places to the left. It will be 0.5. I recommend putting a 0 in front of your decimal point if there is no number there, just to make it easier to see that decimal point. If we had 1.8 kiloliters and we want to know how many liters that is, we're moving from kiloliters to liters, which is 3 places to the right. So I do the same thing with my decimal point, because each time I move to the right, each step I multiply by 10. So this would be 1,800 liters. We'll have the same scale for mass. For mass, we have our 7 units, but instead of liter or meter for our base unit, we have gram. Otherwise, it's identical, and we move on this scale exactly the same way as we did with those 2. So for example, if I had 4,000 milligrams and I want to know how many grams that is, I start at milligrams and I move 3 places to the left to get to grams. So I move my decimal point 3 places to the left, so that will be 4 grams. That's all we need to do to change from one unit to another, is move our decimal point. One thing I want to point out when we're talking about mass, you might see a metric ton as a unit, and it doesn't really follow the typical rules of our metric system where we take our base unit and attach a prefix. If we did, a metric ton is actually a megagram, which I'll talk about in a future video. The unit exists to have something comparable to a regular ton. Now we know a regular ton is 2,000 pounds. A metric ton, which has a symbol of small t, is 1,000 kilograms. So if we were to put it on our scale, we would actually have to put it 3 places over to the left of kilogram. So I just want to point that out in case you encounter that unit. Practice changing from one metric unit to another metric unit, and either use the values of the prefixes or these scales to do so. In the next video, I'm going to talk about measuring area in the metric system.